Continuing where we just left off, a boat went 48 miles in 3 hours. What was its speed? So we have another distance equals rate times time problem. How do I know it's a distance equals rate times time problem? Because they're giving me distance, rates, and times. Tell me how far something's traveling. When they're talking about traveling, it's going to be distance equals rate times time. So we've got a boat here. That's the first thing to check. Is it one thing traveling or two things traveling? If it's only one thing traveling, it's just going to be a d equals rt. Here's our d equals rt. What did they give us? It went 48 miles. 48 miles, is that a distance, a rate, or a time? This is a distance, so we're going to go put that in for distance. 48 equals 3 hours. Is 3 hours a time or a rate? 3 hours is a time. Put a 3 in for t. What was its speed? Speed, rate, same things. I don't know r. So I have this equation, 48 equals 3r. I can solve for r, divide by 3, divide by 3. R equals 16. Easy money. Next problem. A plane traveled 2,050 miles flying at a speed of 410 miles per hour. How long did it take? Is this a distance equals rate times time problem? Absolutely. How do I know? Because they're talking about something traveling. Is it one thing? Is it more than one thing? It's one thing. It's just a plane. So I just have my plane traveling. So I'm just going to use distance equals rate times time. I don't have two things to worry about. I'm only going to have one equation. Traveled 2,050 miles. Distance, rate, or time? Distance. 2,050. Flying at a speed of 410 miles per hour. 410, is that a rate or time? 410 miles per hour, rate or time? Got to be a rate. 410. It's talking about what the speed, how fast is it going? That's a rate. How long did it take? How long? Time. T. Don't know that. I'll figure that out. So my equation, 2,050 equals 410 t. Divide by 410. Divide by 410. And we figure out t equals 5 hours. Beautiful. These are simple distance equals rate times time problem. First one we had to find d, second one we had to find r, third one we had to find t. We can find any of those things without too much trouble. So the next thing we want to do is we'd like to be able to do a harder problem. So let's look at something like this where I have more than one thing going on. Train leaves town heading east at 40 miles per hour. 1 hour later, another train leaves town heading east, traveling at 50 miles per hour. How long before the second train catches the first train? How many miles was the trip? So I've got two things going on. I've got one train leaving town. Here's my first train. It leaves, and then my second train takes off an hour later. So an hour later, that other train takes off. Here's the deal. I have two things going on, so I need to figure out what's the distance, rate, and time for each one, and then figure out some kind of relationship. So let's do a d equals rt for each one. Here's my first train, d equals rt. Does it tell me the train leaves town heading east at 40 miles per hour? That's the first train. What did it give me? It gave me 40 miles per hour. That's a rate. So my equation for this guy, distance equals 40 t, and that's all I know. Second train, 1 hour later, another train leaves town heading east, traveling at 50 miles per hour. Okay, we can get a d equals rt for this guy. Do I know the distance? No. Do I know the rate? Yes, 50 miles per hour. That's from the problem. Time. Do I know the time? Not really, but like I said, if we have two things going on, we got to start figuring out relationships. It said this guy leaves 1 hour later. The second train leaves 1 hour later than the first train. So the time that it travels for, if it leaves 1 hour later, it has 1 hour less time to be traveling. So its time, it's the same time as this, minus 1 hour. I just have to take away one of those hours because it doesn't get to travel that hour. It left an hour later, it doesn't get to travel that hour. I now have two equations. Is there any way to relate these two things? My problem is this. How long before the second train catches the first train? So I need to figure out a t. And how many miles was the trip? So I got to figure out a d also. What's the relationship between these two things, though? The relationship, and you'll see a lot of problems like this, you want to know, when does the second train catch the first train? How does that do anything for me? If I want to know when the second train catches the first train, if here's my two trains taken off, here's my trains going again, I know this one left later, But I want to know, when are they at this exact same spot right here? When are they both at that exact same spot? Well, if they left from the same spot and they finished at the same spot, what do I know about the distances? They're the same. D's are the same. Distances are the same. If my distances are the same, then look what I can do. That means these two distances are the same. But all these things are equal. 40t equals d. Well, d equals d. D equals 50t minus 1. Which means 40t equals 50t minus 1. Since their distances are the same, I can set these two equations equal to each other. One equation, one variable. This is easy money. 40t equals 50t minus 50. Easy money. Subtract 50t from both sides. We could do this all day. Negative 10t equals negative 50. Divide by negative 10. T equals 5 hours. So, did I answer the question? How long before the second train catches the first train? I know t is 5 hours. Just figured that out. How long does it take the second train to catch the first train? Well, it takes 1 hour less than that. So the second train is actually only going for 4 hours. Second train traveled for 4 hours. Why? Because if t is 5, t minus 1 is 4. So the second train actually only traveled for 4 hours. The other question I have to answer is, how many miles was the trip? How can I figure that out? Well, the easiest way to figure that out is, I know t was 5 hours. So if I go back and look at the first train, if t is 5 hours, then I can figure out d, how many miles, it's a distance. 40 times 5 equals the distance. So to answer the second part of the question, distance equals 40t. T we just said was 5, so d equals 40 times 5. D equals 200. And we're done. Not that this is particularly easy on the first go around, but we figured out d equals rt. We had two equations. We figured out what's the relationship between the d's. The distances were the same because they were going the same way. We want to know when they caught up. Solving an equation, we know how to do that. Answer the questions. Make sure we're actually answering the question. It says how long before the second train catches the first train. Well, it only took 4 hours to do that. And then we could figure out the distance by plugging in an answer. And have we answered the question? We've answered the question.